Hi, I'm an old guy and I do maths. And one of the things that I very, very rarely do is put two similar videos close together in time, let alone two videos that are basically the same. So you will have seen from the header, if you're a regular visitor to the channel, that the problem that I've posed is almost exactly the same problem that I posed a week ago, which is to find the area of this circle given the information that we have. Now this is badly drawn, but again, if you look at the header for the video, you'll see a well executed version of this. But this is all we need to figure out the area of the circle. So why the first question? Well, that comes back to a comment that was left by someone who said that my calculations for this this segment of the chord here were correct, but that the circle could not exist. And that got me really, really curious. And so I thought, well, I suppose there are a few ways of doing this. Another person left a message saying that they had drawn the problem out on Desmos, and that the points of intersection on the circle with the various chords were correct. Well, that doesn't give me a great deal of comfort. But thank you for the message, and thank you for the person raising the question. This is not an attempt to get at them at all. What I want to do is I want to show how I went about making certain that this circle could exist. So, as I say, there are a few ways of doing this. I chose to use construction. So what I have here is some metric quad paper, and I'll just show you what we've got here. So you can see that is 10 centimeters, and I should make the point, which I did in the previous video, that I have assumed that what we are dealing with is a series of squares, because if we're not, then I can't off the top of my head think of a way of solving this problem. So I've assumed that these are squares, and I've drawn them to scale. So 16, side is 4, that side is 4, 25, that side is 5 centimeters, that's 5 centimeters, and this is 10 centimeters across here. Now, to some extent, I've spoilt the surprise, because I've got a mark here indicating that I have tried this. Now, what do I need to do to get to the point where I can figure out a radius for this thing if I'm doing it mathematically? Well, what I need is I need this distance from here to here. So how do I find that? Well, we'll come back to the construction in a moment. So taking this page away, if I just deal with the two lines that I have, and I know that from here to here is 5, and I know that from here to here is 4, and I know that from here down to here, if you can see that, is 10. So just coming back to this, that's the measurement of 10 down there, that is 5 across there, that is 4 up there, and That's the number that we're looking for across here. Well, circle theorem tells us that this times this is equal to this times this within a circle. Now, the 10 comes out to here. We're somewhat short. So what we're looking for is we're looking for this measurement here. Well, 4 times 10 is 40. Therefore, this will be 8 because 8 times 5 is 40. So our missing measurement is 8. Now, if I go back to my construction, that means that from here to here is 8. And from here to here will also be, from here to here is 8, and from here to here is 5, and from here to here is 4, and from here all the way down to here, is 10. So we now have a series of measurements for everything within the bounds of the circle. This point, and this point, and this point down here are where the circle hits, or should. Okay, so if I'm going to do this by way of construction, I need to find the center of the circle, and quite simply what I do is I use this line from here to here and find its midpoint. This is 8 plus 5, which is 13. The midpoint will be 6.5, which I have marked, but you can see that there on the ruler. 6.5 is there. Moving down along this line, we have 14. The midpoint of that will be 7. So if I measure 7 from the point here, I get to here, and where lines of these intersect, I have the center of my circle. Now, this is the part of the construction that sets out to show that this circle can exist. So if I place my compass here and here, and just bear with me because I'm not the world's greatest drafts person, but what I get is the following. Now, as you can see, my hand didn't leave the compass. There is the circle drawn with a $2 compass from a local stationery shop, and it's as accurate, I think, as we need to be. Now, what we can do, and bearing in mind this is not terribly accurate, it looks like our radius is just over 7 centimeters. So let's set about finding exactly what it is. Now again, fair warning, this is obviously not to scale. The last time I found the area of this the circle, I used the center point of the circle and the fact that I knew this measurement from here to here, so there we are, just drawing that in roughly, and this measurement from here to here, so this was, I think, 3 from memory, and this was 6.5, and I could use Pythagoras to find the radius, and of course pi r squared. That's all I needed. Now I'm going to do this, I'm going to find the radius another way this time. And here we have our formula. 4r squared, so we can find a radius, is equal to a squared plus b squared plus c squared plus d squared. Now, all we have to do is give these names, a, b, c, and d. And because we're adding, it really doesn't matter which way we go with this. So if we want to get the radius squared, which is what we need to find the area, because area of the circle, so if I just very badly draw in a circle, that's a really lumpy circle, but forgive me. I'm looking at the camera as I do it, and it's not that easy. Well, not for me. Area is pi r squared. So if we can get r squared on its own, if we can get this on its own, all we have to do is multiply by pi, and we'll get ourselves an answer. Okay, so rearranging this is pretty simple. R squared is equal to a squared plus b squared plus c squared plus d squared on 4. Right, let's go to work. We know that, we know that, we know that, we know that. So we have got a squared, which is 16, plus b squared, which is 100, plus c squared, which is 25, plus d squared, which is 64. And that comes to 205. There we are. Divide that by 4, and we get 51.25. So r squared equals 51.25. Those of you familiar with my previous video will recognize this number. It's the number that I got for r squared in the last video using the triangle method. Next move, multiply that by pi. There is our area, 161, we'll call it 0.01. 161.01 units squared. So thank you very much for watching. I hope you found this interesting, and I hope that I've satisfactorily explained that the circle can exist and an alternative way of finding its area. So thanks again for watching. Thank you to the person who initially raised this point. I'm very grateful because it's given me an opportunity to do some more work and to show you another method of dealing with this. And if you found this useful, please like and subscribe, and I'll see you next time. Maybe have a look at the previous video too. Bye.